All right, let's look at an example for finding the center of mass, right? Let's say you have a rectangular region, so which is drawn here, and the density is given by x times y. All right, so part A, let's find the total mass, m. All right, so m is going to be, can be found by integral over this region R, and then mass element, so we can probably use dm, right? But mass element is simply, so maybe I'll probably write it here, dm is simply rho times dx dy, so density times area element. Alright, so we're going to get, so we have an integral. It's going to be a double integral. So rho is xy, so you have xy. Then we have dy dx, so d or dx dy, that doesn't matter. Alright, so since we are doing with respect to x first, x value is going to go from 0 to 3, so 0 to 3, and the y value is going to go from 0 to 2. So it's a rectangular region, so it's very easy to find the upper limits and the lower limits. Alright, so let's go ahead and evaluate that. Alright, since y is just going to be a constant when you take the antiderivative with respect to x, so y is going to stay there. So we can actually put it outside. So why don't I do that? So 0 to 2, right? I'm going to just put y outside, right? Then antiderivative of x is just x squared over 2. And then you're going from 0 to 3. X goes from 0 to 3. Right, then we have d with respect to y. Right, so this is going to be equal to, so you still have, so integral from 0 to 2, y, right, plugging 3 there, so you're going to have a 3 squared over 2, so it's going to be 9 halves, so 9 halves, and dy. Right, so we take the antiderivative, right, 9 halves is just going to be a number, I'll just put it right here, 9 halves, and the antiderivative of y is going to be y squared over 2, and then we're going from 0 to 2. Right, so if you plug in 2 here, 2 squared, 4, 2 cancel out, so you're just going to get 9. So 9 is the total mass. Right, so let's look at the part B. Right, now we want to find the center of mass, so x bar and a y bar. Right, so we need to find, first we want to integrate over the same region R and x dm, the mass element. So this is going to be equal to, again, integral. Right, so m is just going to be xy dx dy, so it's going to be now there's x in front, so x squared y dx dy, and then we're looking at the same region, so x is going to go from 0 to 3, y is going to go from 0 to 2. Right, so let's evaluate that. So you have an integral from 0 to 2, right, so y is just going to be a constant. Then you have a x cubed over 3, and then you're going from 0 to 3. Alright, so then, so with respect to y still, so this is going to come out to be, plug in 3 here, so 3 and 3 cancel out, 9y, so you have a 9y, and integrate it from 0 to 2, and dy. So antiderivative would be 9y squared over 2, and then you're going from 0 to 2, right? plug in 2 cancel out, so it's going to be 18. Right, so we know that x bar is going to be 18, which is we got. Then we still have to divide it through by total mass, which is 9. So it's going to be x bar is going to be 2. All right. And a y bar is the same way. We can just compute the y bar in a very similar manner. So first we compute the numerator first. So y dm, which is so same region, so it's 0 to 2, and x goes from 0 to 3, right? So xy times y, so it's going to be xy squared dx dy. All right, so you have an integral from 0 to 2, and y squared is just a constant. Then antiderivative of x is x squared over 2. Then you're going to go in from 0 to 3. All right. Then you can see that this is going to give us 9 halves. So it's going to be integral from 0 to 2 and 9 halves y squared and dy. So we can just take the antiderivative. So it's a 9 halves. Antiderivative is y cubed over 3. Then you're going from 0 to 2. Alright, first we can cancel 3 on the bottom and 9, so you have a 3 left over. And plugging 2 there, so one of the 2's cancel out, so 4 times 3 is 12. Right? So which means that if you want to find the y bar, which is going to be 12 divided by 9, which is going to be 4/3. Alright, so we have that. So therefore, if you want to find the center of mass, which is x bar comma y bar, came out to be about 2, not about, exactly 2 comma 4/3. Alright. So so in the picture, looks like it's going to be around here. So it's going to be, here's a 1 and 2. So that's 2 comma 4/3. So 4/3. So it's going to be 1. So it's going to be slightly larger than that. So it's a 4/3 right there. Right. So it's going to be around right here. So that's going to be our center of mass. Right, so you can see that based on the density, as you go far away from the origin, that means that the larger x value and larger y value, the density is going to be higher. So you can see that the center of mass is going to be closer to the this far edge here. So it's around here. It makes sense, right? So but anyway, so this is how you find the center of mass, right? That's it. I hope that this was clear.